Assalamualaikum and a very good morning. It's me, Nurishali Sopi, as your anchor for today, and you are watching a science news. Let's have a look at the headline first.
What is a biosensor? A molecular biosensor is a sensing device that measures specific molecules known as biomarkers. Molecular recognition is used for detection of biomarkers, working in conjunction with the reader. The biosensor operates by detecting a sample taken from the interstitial fluid and is worn either inside or on the body for continuous monitoring, with glucose being the most common biosensing device used by diabetic patients. The process begins with molecular recognition, followed by signal generation, reader instrument, and a disposable sensor device. Biomarkers bind to the recognition molecules, and they can be either an antibody, an aptamer, or an enzyme. This results in a signal generation inside a disposable sensing device, and the signal can be optical, electronic, or magnetic. The signal is then translated, and the disposable sensor device then displays this into data and information that is user-friendly and easy to understand. Our biosensing devices have a wide range of capabilities that can be applied to different aspects depending on the user's specific needs. In recent years, we have developed biosensors used in the analysis of food, such as chili, garlic, ginger, and star anise.
To find out more about this, I will give to my reporter together with the scientists to explain more about this. Hello, Shirley Tan, are you there?
Thank you, News Anchor. Today here I am at Faculty of Bioscience T02. I have three scientists here to explain more on the paper biosensor. Good day, Ms. Sharon. So I believe all of the end user want to know what is the significance of this biosensor.
Okay, so actually conventional methods of detecting pollutants are really expensive and high maintenance. So biosensors can significantly cut the cost, and also it's rapid, highly selective, and also highly sensitive.
I see. Hi, Missy. May I know where can we apply this biosensor in real life and what are the benefits?
Okay, the main application of this biosensor is to detect harmful phenolic compounds such as catechol and resorcinol in various industries. So it can be used in wastewater treatment plant and also in manufacturing industries such as pesticide industry, dye, and also any textile industry. So there are various benefits and advantages for this biosensor. First, it has a rapid and easy detection system. It can detect the pollutants within a minute. And next, it can show the result and it can be visually detected. So we can observe the color change from faint pink to red or even orange in the presence of phenolic compounds. And thirdly, this paper-based biosensor employ paper-based, so it uses Workman filter as the main components. And this filter has several advantages, and it is biocompatible, biodegradable, and it is mainly chemically inert. And besides that, this Workman filter will use capillary action to move the liquid.
Alright, now that we know where it is used and its importance. So could you please explain how this paper biosensor works?
Okay, so how does it actually work is that we have this paper with the enzyme on it. So we have the water sample. So we put the water sample in contact with the paper. So the enzyme on the paper, which is the horseradish peroxidase and the oxidoreductase, will catalyze the oxidation of the catechol and resorcinol into benzenosenequinone. Sorry, it's a bit too long. And then this benzenosenequinone will react with the chromogen and BTH. So this chromogen is actually faint pink originally in color on the paper, and then after reaction with the analyte, and then it will turn color based on what kind of analyte it reacts with and the concentration of the analyte itself. So for the catechol, it will turn the faint pink into red, whereas the isocyanates will change the faint pink into dark orange.
That's fascinating. Well, as a knowledgeable personnel on this matter, so what is the pros and cons of using this biosensor?
Alright, so the pros of this biosensor, it's very easy to use because it's only one step, and then it's very time saving and efficient. And another thing is you only need a minuscule amount of the analyte, which is only 10 microliter, and so a little amount of the enzyme, which is around 15 microgram per milliliter. As for the cons of this paper biosensor, the first one is regarding the production of hydrogen peroxide based on the enzyme, which is HRP and oxidoreductase. So this hydrogen peroxide will cause toxicity and also cause interference, and at the same time will reduce the sensitivity and the reliability of the paper biosensor. Okay, so the second one is it's very hard to maintain the pH of the paper biosensor, which this paper biosensor required at the specific range from 6 to 6.5 pH. And then the last thing is that because it depends on the color intensity and color changes, so we need a pre-existing chart so we can compare between the color, which color is complementary to which analyte and the concentration differences.
As scientists, improvements are the nature of research and development. So what are the improvements that can be implemented to overcome the challenges?
Okay, so the challenges for this biosensor is that it needs a lot of hydrogen peroxidase to work, to detect the catechol. So it needs about 6 times more hydrogen peroxidase to detect about 1 time of catechol. So to overcome this challenge, we can actually bind another enzyme called glucose oxidase to the horseradish peroxidase. So the glucose oxidase will produce more hydrogen peroxide so that the horseradish peroxidase can utilize that hydrogen peroxide to detect the catechol.
So thank you to all the scientists for this insightful information. So back to you, news anchor.
Thank you, Shalitan, for the information. At the end of the news, it concludes that the use of paper as an immobilization metric with polymer entrapment allows the construction of the cost-effective, portable, disposable, and stable biosensor. That's it for today. For further information, you can check our website at www.sciencenews.com. Till next time, see you.